So this is the value 11111. So it is multiplied by this original pixel information. Then it give the output. So this is the formula. So basically, low pass filter is used for cloud removal and noise suppression. Then different low pass filters are like this, and it is just multiply. Then that give different resultant. So this is the low pass when this is the satellite image, original image. When applied this filter, then the resultant image is looking like this. This is the low pass filter. Then high pass filter is generally there is a unique pattern that is in this kernel of 3 into 3 rows and columns. So middle part is the positive value, and the surrounding area is negative value. Suppose this is one of the kernel, -1, all this surrounding information is minus in the negative values, and the middle is positive. So like this is also the high pass filter kernel. So this is applied to this original image. So these values are very high, so as compared to the low pass. So it drastically changes this the resultant image in the satellite image. So it's very, it looks the its sharpness is very high. So some of the linear features are easily identified. So it is not useful for the image interpretation and other image analysis. For any edges identifications, boundary identifications, and some road connectivity identification, so these high pass filters are used. So this is the application of the high pass filters. So these are the some of the example of these kernels. So kernel is generally the uh, consist of only the matrix of 3 is to 3, and it has some values. So it can multiply with the image pixels. So generally the image pixel is also one of the matrix form. So each image is constitute of some rows and columns, and lot of pixels are there. So they are arranged just like this type of kernels, and these values are multiplied with all this value of the satellite image. So these are the some of the example of the high pass filter kernels. So when original image is applied with the high pass filter values kernels, then it gives the different results. So it is the giving the different edges, different road, and different road and connectivities are just giving the uh, information, detailed informations. Then this is the band pass filter is there. So it is a special filter that passes within a certain special frequency range is there. So different frequency range is applied. So it is generally the middle of the low pass filter and high pass filter. So it's balance the low pass filter structure and high pass filter structures. So it gives some of the good results most of the times. So this is the band pass filter. The A image is, and the B is the low pass, and the high pass filter is the black image. So most of the time the band pass filter is used for geology, urban story, vegetation mapping, and oceanography. Then band ratioing. Band ratioing is the generally used. Why we are using the band ratioing? So generally band ratioing is used to remove the illumination effect and some topographic effect to the satellite image, and some of the to identify some of the important areas by applying the ratio of the bands. So generally for NDVI calculation, so in the NDVI there is the normal differential vegetation index. So it gives the vegetation, it highlights the vegetation informations. So it is the formula is the near infrared minus red by near infrared plus red. So why we are using near infrared and red? Because in the near infrared, the vegetation give the highest reflectance, and red it is not as compared to the near infrared. So the ratio of this give the good values for the vegetations. So it is ranges from -1 to 1. So some of the healthy vegetations which are giving the resultant, that is 0.6 zero point 0.6 to 0.9 or 1. So 1 is not shown most of the time, but 0.6 to 0.9 is the, it signifies it is a healthy vegetations. So all this pixel information are we can gather. So then we just uh, calculate and categorize that this area is healthy vegetations areas. But in the satellite image we cannot get the that type of information, but in the band ratioing technique we can get this. So a lot of other applications are there, like ndvi is also for vegetations. Ndvi, that's normal differential built up index, where the most of the urban areas and built up areas are highlighted. Like this ndwi, they like a normal differential water index, where water bodies are highlighted. So like a different mathematical formulas are there for different index. So all these index are based on the band ratioing techniques. So which bands are used for different calculation of different ratios. So some of the individual band have different characteristics for particular features, and some of the uh, high wavelength bands have different characteristics. So by ratioing all these bands, we get the output of one of the image, and this image gives the different outputs for particular purpose. That's why we are using the band reflectance. So these are the example of the band ratios. So the original image is converted into band ratio images. So how this is calculated the ratios? So this is the image of the pixel, image of this areas. Each pixel have some values, and the reflectance values are there. So we just calculate by ratioing, that is band 3 divided by band 2. So it means the pixel value is 10. So the 10 means the reflectance value of the pixel. So 10 divided by 2, then the resultant is 5. So likewise, all these pixels informations are all the ratios are calculated. So how this ratio are calculated? So each pixel is a georeference. So each location of this particular pixel is related to second band. Then each of these pixels are calculated based on their locations and informations. So this ways the band ratio techniques are helpful for identification different features. So previously we just discussed all this. So now uh, how this band ratio is used, how calculated in different softwares, we just we just see. So now various softwares like GIS software and uh, mm, remote sensing software are using the NDVI calculations and other band ratio techniques. So today we will check whether this calculation can be done, can be possible or not in the R programming. So in the programming level also we can calculate different ratios and different indices of the, so all the remote sensing satellite images. Okay. So today we will discuss. Okay. So today we will discuss the introduction to R programming in the field of remote sensing. So generally, R programming is used for the statistical analysis and giving the different visualization of the data. So it is most powerful visualization programming techniques. So it gives a lot of information of the data with the help of the different techniques of the visualizations. So it has different packages are there, lot of packages are there nowadays. Lot of packages are available in the field of remote sensing. Also it is used for the data science, mostly used for data science. And in different sectors are also used. So basically R programming is nowadays used in the research and academics, IT sector, and in finance. So because finance, most of the data is there. Then e-commerce, and social media, and bankings, and also in remote sensing uh, field. So nowadays, R is very much helpful for analysis the remote sensing satellite images. So that's why we are included this. So this is some of the basic of the programming. So why the programming is used for this generally the process of designing, writing, testing, maintaining the code. So all this programming has some code based analysis. So most of the basic terminologies are the like program, then code. So code is generally the instruction retaining programming language. Then compiler, that is convert high level code to machine learn language. Then interpreter, syntax, algorithm. Then types of language. So low level language like machine language and assembly language. High level language, that is C, Python, Java, etc. Object oriented language like Java, C++, Python. Then scripting language like Python, Java, and PHP. So these are all related to this. So some of the common structure like constant statement, if else, and if switch, looping concept is there. And what is the application of the programming like web development, app development, data science, Python, R. These are the things. And some advantages of R programming is like open source. It is open source software, and it is a lot of array of packages there, and quality of plotting and graphing. And there's a lot of statistical analysis can be done with the help of this R programming. And machine learning operations are also available, high quality reports and high comparables for the using of this. Then there are then what is the R? So R is a programming language and environment for statistical and computing and graphics. So basically, it is useful for statistical analysis and graphing. So in the remote sensing, lot of statistical analysis are there. So previous class we just saw the different statistical analysis best techniques are used for the image analysis and histogram and other uh, image enhancement techniques are there. So a lot of statistics are involved for the image analysis. So these statistics can be applied in this R program for giving the different output. So it is a open source and widely used in data analysis, machine learning, GIS, remote sensing, statistics, and visualizations. And it is developed in 1990s. And generally it is a collection of packages for diverse analytical tasks and excellent data visualization using ggplot, and other packages are also there. Then generally it is used in academics, research, and data science industries. So today we'll see how can we get this software. So there are two software in R, that is software R is there, and another is R Studio. So we have to install both of these. So we can most of the time we use R Studio. So it is very much easy for analysis, and this is a very good good platform. So just So just I just give you the link. So just download this software. And these are the two R and R Studio. So you can download. So this is the software link. You can download from this. So download R for Windows. So just install the R. Likewise, you can download the R Studio desktop for Windows, and it is also available download of R. So first install the R, then install R Studio. Okay. So now this is my R software. So I can just, and this is my R Studio. So so in this R Studio, there are four windows are there. One is source, so where we can writing the code, different codes. Then the right side there is environment, so different environments are there. So how this is working. Then the left side that is lower left there is console. So how these codes are executed, it is shown in this windows. Then the right side that is the lower rights, that is the output windows is there. So lot of how these graphs are all these graphs are displayed when we writing the codes of the different different CSV based data or other analysis. And in the right side output, it is also we can download all the packages. So these are the four windows in the R. So this is the open panel. Like this, all the codes are written. Then it is the R console panel where commands are shown here and non-graphics output errors are displayed. Then all this plot, all this package and help pens are there in this output windows. And this is the environment pen, that is dataset parameter list and what is imported and created. All these information are given this. This is the file. How can use the, we can save it in the save as file, and we just import some R programming file. So all these columns are there. So before working on this, so we have to set the working directory so that our all this data are directly imported from this directory. So at a time we have to give this command so that it is created. So suppose as a example, So this is the command, just get wd, then just run. So in this, I just in the lower side, so this in the console windows, it shows that our directory is in the C user on drive and documents. So we have to change this drive. So what is the code for this? Set wd, then we have to write the path. So we have the all this coding part. That is the this is the area. So we have to work on this. So all these are programming data are there. So we have to change this directory. So just copy this path, then so this is the wrong slash. It is like this. Just run it. Okay, just it's double quoted, then run. Okay, then all this data can be saved in this directory. So just check what is whether it is showing or not. So so this is the directory, R programming code and files. So this is like this. So then we have lot of packages are there, and I just go to the slide. So we can use in this area. So there are two type of command is there. So this is the one of the symbol or equal to. You can give any of this symbol to use our coding. So a lot of packages are there. So ggplot is one of them. So we have to download and we have to install all these packages. So out of this, one of the packages is, so already I have downloaded a lot of packages. So we have to install packages. So so these are the especially core JS and special data handling packages are there. SAF, SP, Terra, raster for raster JS, satellite data analysis, and RGDEL and RGOs, ggplot for visualizations, tmap, map view, leaflet. Uh, so one of them just like I just installed the cartography. So just install dot package cartography. So this is my one of the package. Just run it. Cartography. I think it is already installed.
I think so. There should be quotation marks within inside the cartography parenthesis.
Okay, just check. Yes, just installed. So in this way we can install, or there is a package, then install. We can search cartography. This is the cartography, then you can install. So both ways we can install the packages. So we have to install uh, all these packages. So basically it is useful for remote sensing and GIS. So already I have installed all this raster, Terra, SF, RGDL, and all these are. So now, now we have to work on one of the Landsat 5 thematic mapper. So it has lot of spectral bands are there. So we have to import some of the bands from our system. So this is the different information of the bands. Band 1 is blue, band 2 is green, band 3 is red, band 4 is near infrared, band 5 is shortwave infrared, and band 7 is shortwave infrared 2. So these are the wavelength bands, and the spatial resolution is 30. All these are 30 in resolutions. So just import it. So just a minute. So suppose we have to import band 1. So just name it as B1. So equal to, so it raster, then so our band 1 file is there. Band 1 is not available, I think. Yes. So band 1 file is L5 underscore B1 dot img. L5 underscore B1 dot TIFF. So it is in TIFF format. L5 B1. I think the naming is different. L5 underscore B1. Is the right?
I think, sir, at some this RAS function is coming from which library exactly? Because that also needs to be, I think, referenced
Actually,
in the network.
we have to install the package. We just give the library of Rust. That's why it is not showing. So library of raster is there. I think this is the error. Raster. Now it is executed, I think. No.
I think now if we, yeah, if we have RAS,
Yes, now it is executed. Then we can plot it. Plot B1. So this is the band 1. So likewise, we can just import all this B2. This is B2. And then B3. And then B4. Yes, so we have generally used blue, green, red, and infrared bands. So in our so there are blue, green, red, and infrared. So we have to work on in all these four bands. For NDVI, near infrared, like the band 4 is really required, and red band is there. Four, three bands are important. So we have to now we have to composite this satellite image. So all these are individual bands. We have to join all these bands to create a, composite band that is colorful band. So for this we have to give the command composite composite 1 or L5 L5 equal to C of B1 B2 B3 B4. B1 B1 band, B2 band, B3, then B4. So these are the bands. Just we have to run it. Then plot composite L5, L5 composite. I think it is not plotted. Composite.
I think there is one typo. E is not
I,
present.
acha, 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 acha. There's a extra E is there. So I think there is a composite library is there. I think. Any libraries related to composite is there? Master is there and thematic mapping, right? RGB.
Maybe it could be a function in raster tracking. Maybe a function composite. Maybe I don't. I'm not sure. But in
Okay,
raster tracking,
just
it could be a function.
okay. We just left it. Then we just plot RGB, so that it can be shown in the different color. I think it is a function. I think composite L5. Then red is equal to R equal to 4, G equal to 3, that is green equal to 3, then blue equal to 2, stretch is equal to linear. It is a linear stretch. Think opposite underscore 5. I think we have to change the name. L5C. Red equal to 4, then green equal to 3, then blue equal to 2, then straight is equal to linear. 2 linear, I think now it will be executed. Float RGB
Can you
library.
just see whether you can change the spelling of it and then maybe
I think one of the plot RGB is also a function. I think. Hmm. Some of the library is not installed. I think.
I think the spelling of stretch also can be corrected. Stretch.
Okay, 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 okay. No, it is not. STRETCH. Plot RGB is one of the under one of the packages there. I think that's why it is not executed.
Maybe Terra package. It could be a function within Terra package. Or
Okay, I just check it
I'm not sure. I'm not sure, but
because a lot of packages are there. ggplot, just check.
I don't think deep layer. Uh, deep layer is a statistical. data
This
management
now
practices.
we after this we use the NDVI calculation. So just checked. So I think all these packages are installed. Not of all plotly is not required. Then library raster is also installed. Stretch red is equal to 4, 3, V is equal to 2. Everything is right. CL5 also. Just check plot CL5.
Maybe sir, you can give one exercise and we can try our own, and then we can discuss.
Okay, okay,
If you can just tell us what to do, and then we can try on our own, and then we can discuss in a separate.
okay, okay. ओके तो अभी देखते हैं नेक्स्ट दिस इज द वी कैन शो द प्लॉट RGB like this is the formula. So for the NDVI calculation, which you just check. So we need there are two bands is required for NDVI calculation. That is band A, band 3, and band 4. So just check. So in this we have the band 4 and band 3 already imported. So generally the NDVI is infrared minus red by infrared plus red. So just check NDVI equal to. So now in this there is a band 4 B4 minus B3 divided by B4 plus B plus power B3. B4 plus B3. This is the formula. So this is our variable. Now just check. Then it is executed. Then plot NDVI. So this is our NDVI image. So in this legend, its value are calculated from -1 to 1. So this is the green area. That is the forest area. So it is value is from point 0.1, 0.5 to 1. So likewise, all these values are calculated in the NDVIs, and we can convert these NDVI values into different raster calculator, the pixel information in the CSV format or in Excel format of each and every pixels informations are we have to check. So what is the value of the reflectance value? So likewise, I have some code. I will share it. So this is the NDVI calculation, and one of these is so this is one of the CSV file I have. So a lot of informations are there, like x coordinates and y coordinates informations are there. So we can get lot of um, plotting like histogram and density plot, bar chart plot. So this is one of the formula. So just check. Just a minute. So just check the directory is right. Master is right. So this is a density plot area. This is the formula. Then bar chart. This is the bar chart. Then box plot. This is the box plot of some of the CSV based on the CSV file of farming area actor. So this is my CSV file. So different farming like rice, wheat, and vegetables are there for different years, and the area of hectares, how much area is contributed. So all these informations are given. So based on this information, we are just calculated all this. So these are all these coding related to the different how to create some line chat, then stock bar, then other informations are there. Then another thing is some 3D plotting is there. So how to create the 3D plotting. So these are the some of the codes. So this is the resultant. So this is the 3D plot of all this in my Excel data of different X value, Y values. So in this way, this is arranged. So likewise, all these calculations like NDVI, then composite of the image and supervised classification, unsupervised classifications, and different indices like NDVI and all can be done with the help of this R programming. So just download all these softwares, then practice all these. So a lot of practice CSV formats are available in the Kaggle websites. So basically, only statistical analysis like supervised, unsupervised, and NDVI and different indices and different regressional analysis and all this graph related data are used for the remote sensing purpose. So these are the codes, and just practice it. If you want, then I will give some basic codes for different applications. Okay. Then next we will discuss the what is supervised and non-supervised classifications, how they are look like. Okay, so any doubt you can ask.
Yes, sir. There were some issues, sir, regarding the class timing.
Okay.
Basically, the next, I think, it's also very difficult to get a response from RC Bhubaneswar, whether through email and phones are also not working. So I thought this is the best opportunity to speak to you. So one is that the class, we have offices. We most of us are working, and office is until 6 o'clock. So somehow we managed to attend the class at 6:30. So is it
Okay.
possible to slightly postpone from and start the class from 6:30 onwards? That is one thing. And also, is it possible to share your mobile numbers?
Okay, okay.
And
So I can.
also, and yeah.
Okay, tell me. After that, I will answer your
Yes,
question.
sir. And also, it's also access to the recordings of the classes because what is happening, like during Fridays, we have to catch a train from one city to another city, hometown. So, Friday classes are very difficult, you know. So, if it's possible to access the recording because it's already being recorded by RC. So, these
Okay,
little logistical things that you can help, that would be very, kind and
okay,
presentations in our code of this class. I mean, we can, we are also very much eager and, find this very interesting and we also want to practice and learn. But
okay,
if it's possible to, somehow help us with these little things, we can, more efficiently learn the material.
okay. So first thing is the timing. So my class timing is 6:30. So if you want to extend it to 5-10 minutes, though it is not. It is possible. So it is not a very difficult. So we can extend to 10 or 15 minutes, 5, 6:40 or 6:45 is not a issue. But from today and the next class, he will be Dr. Rakesh Thakur, so one of my colleague. So they have the 4 class. So uh, we have to uh, contact him. So their class, I think, in 6 p.m. So just ask the Rakesh Thakur in our website group. So please kindly arrange the class in the 6:30 or onwards, so that they will arrange this. Second thing is I will provide the contact number. There is no issue. So after 5 minutes, I will give the contact number for any queries. Third is the record of this season is not actually created by me. So this is recording is from the IGNU class, IGNU office. So they have the recording. So I have not some uh, any other recording uh, permission is there. And fourth is I will provide all these uh, remote sensing data, small data, so for practice, and some codes for basic codes for analyzing all this data, and the link for the software and some basic analysis related to R, so that you can practice it in your home. And obviously it is very much helpful for you if it is if recording is available to you. And I will ask their administrative department if it is available, then they will provide. So from my side, I will request them. And this is the thing. So next, any queries? Okay, Binay, just tell me.
सर ये 3D प्लॉट का क्या यूज़ है? और आप जैसे कर्सर आप मूव करके फिर रन कर रहे थे, तो वो क्या कुछ यूनिट टेस्टिंग के लिए होता है क्या, जो आर स्टूडियो में आप
हाँ, जब वो
करते हैं?
3D जो डाटा को डिफरेंट डिफरेंट विजुअलाइजेशन एंगल में कैसे करना है। तो सो देखिए, जनरली आर स्टूडियो इज हैव ए लॉट ऑफ ग्राफिकल रिप्रेजेंटेशंस। सो आप रिमोट सेंसिंग डाटा को आप अगर रिसर्च पेपर या रिसर्च के लिए यूज कर रहे हैं, तो आर से अगर करेंगे तो आपका रिसर्च पेपर जल्दी अप्रूव होने का चांसेस है, क्योंकि वो लॉट ऑफ स्टैटिस्टिकल बेस्ड ग्राफ दे कैन क्रिएट। तो वो कोड सब मैं दे दूंगा जो और विथ बेसिक डाटा. सो फॉर दिस यू कैन प्रैक्टिस. उसको आपको ये मेरा जो व्हाट्सएप ग्रुप में उसको जिप फाइल करके इंडिविजुअल कोड
हाँ
दे दूंगा. ओके. और
सर
मेरा,
व्हाट्सएप
हाँ, अगर कोई
मतलब
मेल आईडी
हमारा
है.
हाँ हाँ मेल आईडी
अदरवाइज,
है।
okay, so give I just give you my mail id,
ओके
so
सर।
just send me your queries so that I will share you.
सर एक लास्ट चीज और पूछना था।
हाँ.
ये जैसे पाइथन भी यूज कर सकते हैं ना, मतलब दोनों के एप्लीकेबिलिटी में क्या फर्क है, मतलब कौन सा कहाँ पे यूज होगा?
पाइथन पाइथन में ज़्यादातर रिमोट सेंसिंग का ज़्यादा काम होता है. पाइथन इससे बहुत ज़्यादा काम करता है, जैसे आर्टिफिशियल इंटेलिजेंस, मशीन लर्निंग और इमेज एनालिसिस, स्पेक्ट्रल एनालिसिस एंड पिक्सल बेस्ड इंफॉर्मेशन. और आर का स्पेशली क्या है कि आर का स्पेशली है स्टैटिस्टिकल एनालिसिस और ग्राफ. जो डिफरेंट, अगर थाउजेंड्स ऑफ इंफॉर्मेशन है हमारे पास रिमोट सेंसिंग का पॉइंट वाइज और एक्सेल बेस्ड में, उसको जो बेटर वो में जो रिप्रेजेंट करने के लिए आर थोड़ा अच्छे तरीके से डिफरेंट डिफरेंट पैकेजेस में आउटपुट दे सकता है. नहीं तो ये जितना भी चीज हमने हमने अभी किया है पाइथन में, सब चीज हो सकता है. सब एवरीथिंग इज पॉसिबल in Python. So Python is a larger environment for remote sensing analysis. So R भी थोड़ा सा बहुत सा हेल्पफुल है, इसीलिए R को भी जानना जरूरी है. तो अगर टाइम होता है तो पाइथन में भी देख लेंगे एक तो प्रैक्टिकल.
जी सर।
क्योंकि मैं एक्चुअली आईटी बैकग्राउंड का नहीं हूँ, तो मेरा बैकग्राउंड ओनली रिमोट सेंसिंग फिजिक्स का है. So I am just knowledge about only remote sensing based analysis in the Python and R programming and some Google Earth engine, and that's why.
एक्चुअली सर मैंने भी गूगल किया था तो दोनों का नाम आता है उसमें, तो इसलिए पूछ।
हाँ, दोनों दोनों यूज कर सकते हैं, लेकिन पाइथन में ज़्यादा आपका पास ज़्यादा ऑप्शन है. पाइथन में बहुत ऑप्शन है. पाइथन में तो आप एक प्रोजेक्ट भी कर सकते हैं कंटिन्यूसली. आर में ज़्यादातर स्टैटिस्टिकल और विजुअलाइजेशन का ज़्यादा है. जैसे आपका जो आर्टिफिशियल इंटेलिजेंस और मशीन लर्निंग टेक्नोलॉजी, आपका जो रास्टर एनालिसिस और जितना भी एक्यूरेसी असेसमेंट, ये सब पाइथन में हो सकता है. इसमें थोड़ा सा डिफिकल्ट है क्योंकि उसमें पैकेज और एनवायरनमेंट बहुत ज़्यादा है. ओके. सो
ठीक है।
I just share my contact number so that you can contact me regarding this. So generally मैं बोल देता हूँ कि actually I am not from IGNU, so I just one type of guest faculty for working for the IGNU. So I am not involved all these administrative related issues, all this. Okay.
ओके सर।
Okay. Okay, Abhimanyu ji, thank you.
Thank you very much, sir. It was
Thank
really
you.
kind of you for your
Okay.
knowledge sharing.
Okay. Thank you. Good night.